take the recap. Okay, what we studied in the previous section. We started with electrochemistry. Electrochemistry deals with the conversion of chemical energy to electrical and electrical to chemical. Chemical to electrical, electrical to chemical. We studied two types of cell. Electrochemical cell is the main topic, in that there are two types. One is called as galvanic or voltaic cell that converts chemical to electrical. Galvanic or voltaic converts chemical energy to electrical energy. Second cell was electrolytic cell. This converts electrical energy to chemical energy. So this was the first point which we covered. Then after that we studied about redox. Redox reaction dealt with reduction and oxidation. Here I told you one trick, RIG, oil. That is, reduction is gain of electron, oxidation is loss of electron. So this element A is getting converted to A. See, there are two electrons and these two electrons are lost. There are these two electrons and these two electrons are lost. Loss of electron is called oxidation. Loss of electron. A has two electrons, both are lost. Loss is called as oxidation. B, without any electron, has two electrons. It has gained electron. Gain of electron is called reduction. So reduction is gain. Oxidation is loss. We studied this thing. The species which undergoes reduction is called a good oxidizing agent. So B, undergoes reduction, is a good oxidizing agent. B undergoes reduction, is a good oxidizing agent, and A undergoes oxidation, is a good reducing agent. So the species which undergoes reduction, good oxidizing agent, and the species which is undergoing oxidation is a good reducing agent. Next, what we studied about it after that, we studied Daniell cell, where I told you one simple word, LOAN, for cell representation and Daniell cells. So what you get for cell representation, L means left, O means oxidation, O means oxidation, A means anode, and N means negative. So if you consider this thing, zinc is your anode, it is on the left hand side. So left anode, oxidation occurs at zinc. Okay, oxidation occurs and the terminal is negative. So vice versa, cathode on right hand side, reduction will occur at cathode and it is on right hand side. So this is from LOAN. So remember this loan word, very important, very helpful. Next, so zinc converting to Zn2+. So from zero oxidation state to +2 means loss of electron. It is called as oxidation. Cu2 plus to Cu, 2 electrons gain. This is called as gain of electron, called as reduction. The EMF of the cell computed as 1.1 volt. So we have to do this also. Now, oxidation is loss of electron and reduction is gain. We have done that. And oxcat is also NOx. Red cat is one also shortcut, but I will prefer lone. Okay. So NOx what? Anode oxidation, red cat reduction, cathode. So oxidation occurs at anode and reduction occurs at cathode. Ye yaad rakhna. Next we went to electrode potential. So electrode potential had few formulas based on reduction potential. Okay? So electrode potential was given as E cell is equal to E cathode minus E anode. So E cell formula is E naught cathode minus E naught anode, and remember this formula is based on reduction potentials. This formula is based on reduction. So their formula is on reduction potential. So reduction potential of cathode minus reduction potential of anode gives you EMF of the cell. So this is what we studied in the last class. Now let's start with today's agenda. Today, what's a recap of the previous class? Dekho, recap le lete hain. The first thing which we studied in the last class, we studied a formula of Gibbs free energy delta G as minus NFE. Delta G is minus NFE. N number of electron. F, I told you 96500 coulomb. E was EMF of the cell. Okay. There were these three conditions, very important guys. Today there will be question based on these conditions. If E cell is positive, then delta G was negative. We saw it spontaneous. For spontaneous reaction, E cell should be positive, and if E cell is positive, then it is spontaneous. If E cell is negative, then delta G becomes positive because delta G formula is minus NFE. So if you put a negative, negative and negative becomes positive. Delta G positive, it is non-spontaneous. Cell will not work. And the last part, which is today's agenda, equilibrium. If E cell is zero, then delta G becomes zero because E cell agar zero, then delta G becomes zero. That's why it is at equilibrium. So this is the old concept which we studied. Yes, this will be called as equilibrium cell. Very good, Shrajan. Now, there is one more thing. Tomorrow's test portion, I guess colligative property and chemical kinetics. Karthik, colligative and chemical kinetics. Hello बच्चा लोग, सबको सलाम. किसी को छूट गया होगा तो बच्चे लोग माफ कर देना. Hello everyone. Now guys, please concentrate. So there is one electrochemical series. This was based on reduction potential. So we have written standard reduction potential. The first point, the most positive value reduction will happen because reduction potential jitna zyada reduction appears. Reduction potential jitna less, oxidation happens. Reduction potential jitna zyada, more the reduction potential, more will be reduction, and more the reduction, lesser the reduction potential, more will be oxidation. Now, if reduction is more, then it is a good oxidizing agent, and this is a good reducing agent. So you can say oxidizing agent power increases this way, and it reducing increases this way. So this we covered in last class. And after this, what we saw different types of electrodes. One was metal ion electrode. Okay. Then redox electrode was a typical example in which we were using a platinum. Platinum is used for a contact because platinum is inert. Platinum is an inert electrode. It is used for contact. So gas electrode or any redox electrode will have platinum. Gas electrode, again you can see platinum. Next was metal soluble insoluble salt. There was a silver electrode. On that silver there was a paste of AgCl. Solid, and the chloride ion was the electrolyte. The last one was calomel electrode, mercurous chloride. There were three layers in calomel electrode: mercury, then mercury ke baad mercury chloride, Hg2Cl2, and on the top of that we had a chloride solution. This was a layer. Calomel electrode has a EMF of 0.28 volt. Remember this. This will come in one question today. So please remember, calomel electrode standard reduction potential is 0.28 volts. So this is what we studied in the last class. I want to take firstly we started with Nernst equation. Nernst equation was the most important equation which is there in electrochemistry. Now, what was Nernst equation? You need to remember E cell is equal to E naught cell minus 0.059 by N log Q. This Q was called as reaction quotient. And this we studied in chemical equilibrium, but still I told you how to find it. That is concentration of product. So yeah, product upon reactant. These were what? Activities, and Q didn't have any unit. Remember, yaad karo, Q doesn't have any unit, unitless quantity. Next we studied for hydrogen electrode. For hydrogen electrode, E cell is equal to E naught. You know that E naught cell for hydrogen gas electrode is always zero because cathode and anode both are same. So 0 volt. Minus 0.059 by 2 log of product by reactant. So product is P2 pressure and C2 square because it will be 2 times H plus here. So H plus square. So this is about hydrogen gas electrode. We solved many questions based on that. Then we gone for calculation of pH. pH is given by minus log of H plus. pH is what? Minus log of H plus concentrated. And then a formula for this particular reaction, 2 times H plus plus 2 electron gives H2. For this reaction, derived this equation also. That is E cell is equal to 2H plus plus H2 gives minus 0.059 into pH. Calculation and equilibrium cell. Remember, whenever there is an equilibrium cell, delta G कितना हो जाता है? Delta G becomes 0 and Q becomes equal to K equilibrium. Substitute these value here. E cell tends to 0. E cell tends to 0. We get the formula E naught cell is equal to 0.059 by N log K equilibrium. So this was done in the previous class. Today, what is our agenda? Today's agenda. So in the previous class, we started with concentration cell. What is concentration cell? Concentration cells were those in which there was same electrolyte and electrode on the both side. Example, platinum, H2, H plus, salt bridge, H plus, H2 and platinum. The cathode and anode both were same. The anode and cathode both were same. And what was the difference? The difference was of concentration. Here concentration C1, here concentration C2. So the concentration of electrolytes were different at cathode and anode. But chalo, concentration cell mein concentrations were different. Secondly, there was one more type in which electrodes are different. That is what? Pressure P1 and pressure P2. So pressure of the gas at cathode and anode were different. So two cases which we studied. Yes, remember it? Concentration and pressure. Two relations which we have studied. अभी hang कर रहा है क्या थोड़ा सा? Yes guys, hang हो रहा है क्या? थोड़ा सा lag है? No? Okay, clear. Wait. Okay, ठीक. Okay. समझ गया. Okay, तो concentration cell में we studied about concentrations and pressures variation. We have taken the questions based on these also. Now, what was an electrolytic? Then we went to electrolytic cell. Electrolytic cells are those in which we convert electrical energy to chemical energy, and during this conversion we have converted a non-spontaneous reaction into spontaneous one by applying external voltage. External voltage लगा के we converted a non-spontaneous process into a spontaneous, and that was done in electrolytic cell. Next, preferential discharge. Ion with least energy will be preferentially discharged. Least energy के लिए which we said, if यार ये कुछ तो lag कर रहा है. E naught reduction potential, if it is more, then that particular ion is reduced. If the reduction potential is more, then that ion is reduced. This we have studied in the previous class. ठीक है? जिसका reduction potential ज़्यादा, that ion is reduced. एक सेकंड मेरे को सब चीजें बंद करनी पड़ेंगी, थोड़ा सा हैंग कर रहा है. Okay, next. Then we went for electrolysis. बच्चा, electrolysis we studied few cases. Molten NaCl. When we say molten form, there is only sodium and chloride. ठीक है? In molten form there is no water. It is pure NaCl. So sodium will undergo reduction. And chlorine will undergo oxidation. We can see at anode oxidation occurs. At cathode reduction occurs. So you can see at anode there is a loss of electron and chlorine gas is evolved. And at cathode reduction is there and sodium is obtained. Guys, I am just refreshing the page once. There is a bit of some issue here. एक बार refresh कर रहा हूँ. Now, we studied then aqueous NaCl. Aqueous NaCl में there is sodium, there is chloride. Aqueous means water is also there, H plus and OH minus. Here we studied a new fundamental called as overpotential, and that is only case of Cl and OH. Remember, that comes in case of Cl and OH. So यहाँ पे between hydrogen and sodium, so you can say that water was having a higher standard reduction potential. H plus means what? There was presence of water. Water has a higher standard reduction potential minus 0.83. If you remember, we have made notes of that. So water will gain electron to give H2 and OH minus ions. So hydrogen gas is released. At anode, reduction is taking, at anode, oxidation is taking place. So there was a winning of OH minus, but there was one concept called overpotential. That's why, because of the overpotential, chlorine gas was obtained. You remember the formula and also the data which I have given to you, 1.48 it becomes. Then
After this is of over potential, very exceptional case. That is in NCRT. You need to read NCRT also once. This is in NCRT and we covered that in very much details. After that, acidulated water means there is presence of H plus, but this is very dilute acid. Dilute H plus, acidulated water. In acidulated water, it's very simple. You get cathode, you have a hydrogen gas, and anode anode पे oxygen gas. In acidulated water, this H plus is undergoing reduction and water is undergoing, अरे यार ये hang क्यों हो रहा है? Water is undergoing oxidation. Okay? That things happen. See, water, that is H2O, undergoes oxidation. Water undergoes oxidation to give O2 gas, and cathode we get hydrogen gas. So this is about acidulated water. After that, we did one case also about copper. So CuSO4 with copper electrode. This is a very special case. Why? In this case, this copper electrodes are reactive electrodes. Copper क्या है? Reactive है. What happens? Let's say if you take a cell, in this cell there is presence of CuSO4. Now you have a copper electrodes. Okay, you made the connection. So this is your positive terminal and this is negative terminal. You know that on, if you are अरे यार क्यों hang कर रहा है भाई? Okay, कुछ चालू तो नहीं है. Okay, now if you are saying CuSO4, these electrodes which are made, these both are made up of copper. Electrodes are copper and electrolyte is copper sulfate. ठीक है? So this negative electrode is cathode and positive is anode. Whereas if we consider a galvanic cell, the polarity changes. Cathode becomes positive, anode becomes negative. Now what happens? In this particular case of CuSO4 and copper, the reactions which are there, okay? Cathode reduction, anode oxidation. Okay? Cathode pe what happened? This Cu plus 2 gains 2 electron to become copper, and at anode, copper undergoes loss of electron to become Cu plus 2. So you can say this aqueous ion is depositing as solid and solid goes into aqueous. So देखो यहाँ पे cathode पे there is deposition of copper happening because this aqueous ion is getting deposited on copper. Cu plus 2 gains 2 electron become copper. So it gets added on to copper. But what happens at anode? Anode pe copper. Okay. Faraday's first law of electrolysis we studied in the last class. In that हमने पढ़ा the weight is which is deposited, it is proportional to the charge. W is proportional to Q. फिर हमने लिखा था W is equal to Z IT because Q जो charge है that is current into time. So W is equal to ZIT we have studied in the last class. Z was given as E by 96500. Okay. Faraday's second law of electrolysis was equivalents were equal. How to calculate equivalence? Given weight upon equivalent weight. This was second law. One term we studied that was current efficiency. Actual mass which was liberated or deposited divided by the theoretical mass. This theoretical we calculate by this formula. W is equal to ZIT. और हमने जो मिलता that is called as current efficiency. Then we studied conductance, conductivity, specific conductance, molar conductance, equivalent conductance, and very good. So first point, we studied, yes, first conductance G, that is inverse of resistance. Then we studied about kappa, that is inverse of resistivity. Kappa is called conductivity, this is called as resistivity. Conductance, resistance. Then there was one formula, kappa is equal to G into G star. That is kappa is equal to G, that is conductance, and G star is called as cell constant, that is L by A. This we studied in the last class. And where kappa is called as, yes, kappa ko kya bolte the? Kappa was conductivity. Kappa is conductivity. G was conductance. And L by A was called as cell constant This we studied in the last class. Then there was formula for lambda. So speak in little big, please, sir. Speak little big, sir. Okay, Kavya. एक सेकेंड ना, we'll just try. थोड़ा सा जोर से बोलेंगे. Yeah. Hello, hello. Okay. एक बार देख लेते हैं सब सेटअप सही है ना. एक. Okay, बच्चा लोग. So KSP. Okay. So KSP के लिए we started with AB types of salt. AB type is calcium carbonate. Then we have AB2 type of salt, that is something like calcium chloride, AB2 type. Then AB3 type of salt, that is AlCl3. In this we know the formulas of KSP from ionic equilibrium. KSP is equal to S square. This KSP is equal to 4S cube. And this KSP is equal to 27S raised to power 4. Now, how to convert the formula for molar conductivity into KSP? Remember, molar conductivity is kappa into 1000 upon molarity. In place of this molarity, bachcha log, in place of this molarity, you can put solubility S. So the formula changes kappa into 1000 by solubility. So just from this formula, you have to substitute solubilities. Okay? You just have to substitute solubilities and answer is there. So molarity, in place of molarity, substitute solubility and the new formula is with you. And this is what KSP. So this we studied in the previous class. We studied alpha is lambda m by lambda infinity. Then we studied Ka is equal to C alpha square upon 1 minus alpha. Yes, after that we studied about Kohlrausch law, in which we studied about ionic part. Then there was a strong electrolyte and a weak electrolyte construction. Strong electrolyte, there is a straight line with a negative slope. Lambda m is equal to lambda infinity minus b into root c. This was the case which we studied. And after that, we studied for different types of cell. So batteries, primary cell, dry and mercury. Secondary, lead storage battery, nickel cadmium battery. Fuel cell, reactants are externally supplied, combustion takes place. Efficiency is given by delta G by delta H into 100. Corrosion, electrochemical cell, spontaneous reaction, rust is formed. Galvanization is what? Iron is coated with zinc. Because zinc has higher oxidation potential than iron. Zinc has more oxidation potential than iron. So thank you guys. Thanks for your time.